Discrete signals from any engine air switch and either pack switch combine to signal this configuration to the TRP. Engine anti-ice on, engine anti-ice selected on and the engine air off. A discrete signal from any engine anti-ice switch signals this configuration to the TRP. When this configuration is used, air conditioning is normally provided by the APU. The selection of APU air by itself does not affect the TRP calculated N1. It is not permitted to select engine air bleeds and engine anti-ice simultaneously for takeoff. If an invalid bleed selection is made with a takeoff setting on the TRP, the N1 set numbers on the PED will flash. If a reduced thrust takeoff is performed, N1 ref is normally manually set in the N1 set window on the number 1 engine for reference. N1 reduced appears in the other N1 set windows. The intended thrust rating for takeoff, either TOGA max or TOGA reduced, is set on the TRP. Note that the rating appears on the top left of the PFD. Reduced thrust must not be used for takeoff with flap 33 or if the runway is contaminated with standing water, snow, slush, or ice. During ground maneuvering and wind speeds greater than 15 knots, do not exceed 55% N1 except for takeoff. The engine anti-ice must be on during all ground and flight operations. When icing conditions exist, are anticipated, or if the ice detected caption is illuminated. Immediately before takeoff, the autothrottle may be armed by selecting the autothrottle switch to AT arm. The green light adjacent to the switch illuminates and AT appears next to the selected thrust mode on the PFD. For takeoff, the thrust lever should be advanced to 45% N1 and either TOGA button pressed. The autothrottle mode displayed on the PFD will turn green and the thrust levers will advance to the target N1. If achieved N1 is more than 1% below target N1, the takeoff should be abandoned. When the wind speed is greater than 25 knots from a direction of 55 degrees or more off the runway heading, do not use TOGA reduced. Perform a rolling takeoff and set takeoff thrust when aircraft ground speed equals wind speed. Takeoff performance is scheduled on the basis that the thrust levers are not moved during the first and second segments of the takeoff. At 80 knots, the thrust level calculated by the FADEC is frozen, and the autothrottle is clamped until 350 feet when FADEC unfreezes and the auto throttle enters the inactive armed mode. The auto throttle remains in the arm state until a new thrust mode is selected by the pilot or is automatically entered by the flight guidance system. Following an engine failure below 350 feet, if full thrust is required during a reduced thrust takeoff, a toga button must be pressed and the thrust levers manually advanced to the bugged value. After flap retraction, thrust rating is set to climb norm by either pushing thrust on the MCP or selecting climb norm on the TRP. N1 is now continually calculated for altitude and temperature by the flight guidance system. Climb norm normally remains selected on the TRP for the remainder of the flight. After the flight guidance system has captured the selected altitude, the auto throttle now enters speed mode and thrust automatically reduces to maintain the selected IAS or Mach. Descent may be made in either level change or vertical speed modes. Selecting level change places the auto throttle in retard mode. The thrust levers retard for 12 seconds before the auto throttle enters the arm mode. In this mode, full manual control of the thrust levers is available. Selecting vertical speed places the auto throttle in IAS or Mach mode. IAS or Mach, as selected on VCEL, will be maintained by the auto throttle. Vertical speed is the aircraft attitude through the flight director and autopilot. During an ILS approach, when the autopilot is in glide slope mode, the auto throttle enters speed mode and controls the speed of that selected in the VCEL window. At 50 feet radio altitude, the auto throttle enters retard mode irrespective of autopilot engagement. The auto throttle should be disconnected on touchdown before IAS is less than 60 knots. If a go-around is initiated, the mode automatically reverts to GA max. This can be reduced to GA reduced by pressing toga on the TRP. After checking the APU generator output, engines 1 and 4 may be shut down during taxi. As a maintenance check, the pilot is required to test the fan overspeed shutdown system on each engine every day. The N1 of all engines should be increased to 30%. The engine overspeed button on the ground test panel for the engine to be shut down first is pressed.
Do it, please.
After N1 begins to decay, the thrust lever should be moved to the fuel off position. Engine overspeed illuminates on the central warning panel. This indication should be cancelled by selecting Flight Start to On and Start Select to Engine 4. The remaining engines may then be shut down using the appropriate engine overspeed buttons. Start Select is rotated to the relevant engine after each shutdown to cancel the central warning panel warning. With the TARP selected, the interface between the FADEC and the flight guidance system is broken. The following functions are now not available. N1 ref and N1 reduced must be calculated using the tables provided in the checklist. It must be noted that the N1 values presented in the tables of N1 for takeoff and go-around take into consideration N1 compensation. Therefore, with compensation not available, 1% must be subtracted from the values derived from these tables before they are entered into the PED. After takeoff, N1 should be manually set for the appropriate altitude and temperature as given in the tables and the MOM. Every 5,000 feet, the thrust lever should be advanced to the tabulated value. The pilot must monitor the EGT to prevent exceeding 613 degrees Celsius. FADEC off. In order to protect against surge, the engine anti-ice of the affected engine must be selected on for the entire flight. If performance is limiting, the engine anti-ice of the affected engine only should be selected on. Performance data must be extracted from the appropriate tables or graphs at OAT plus 4 degrees Celsius. If takeoff performance is not limiting with engine anti-ice on, all